Hey guys, I wanted to try something here. You guys know I put a new motor on my Quincy 325 compressor here back in, I think it was November. Time flies. The one thing I noticed, that because it's such a hard starting load, because there's a lot of inertia there, that there's excessive amount of amps on startup. And I thought, well, what would happen if I were to take my soft start from my dust collector and put it on this compressor? Keeping a couple things in mind that number one, a single phase soft start, you really want to minimize the ramp time and startup torque, because you're essentially kind of doing a controlled stall with a controlled voltage going to the motor. So if a motor is rated for 230 volts, it should be running on 230 volts, give or take, plus or minus probably 10-15%, depending on what your line voltage is. But anyway, so essentially what a soft start does for single phase, the one that I got here is a Baldor. It's upside down right now, but I've just got it temporary hooked up. I just want to make sure if it works, and if it does work and I have a lower amps and startup to what I think is reasonable, I will probably order one. There's a couple different manufacturers out there to make them. A single phase soft start is not as easy to find as a three phase. And one's not to confuse a single phase soft start with Y delta controls for starting three-phase motors, which I was always referred to as poor man's soft start. But anyways, so if this idea works and I feel it's satisfactory, I might buy another one. I don't know if I'll buy the same one, but getting back to two manufacturers, Baldor's one manufacturer, and there's another manufacturer out in the, I think the United Kingdom maybe. And I can't remember the name of them right now, but they were also, actually there's three manufacturers. There's one in the United Kingdom and there's another one called Power Boss. Now, Power Boss and this other one, they've also tried to take this technology where they basically have what they call a power saver. Supposedly it monitors the motor's energy, and if it feels it's drawing too much, it will basically lower the voltage, and I think it's just the voltage. I don't remember how it goes. You can go to powerboss.com or go to YouTube and look at for Power Boss soft start. And I know we tried one at the company I worked for, and we tried it on a 50 horse blower for a dust collector, and we didn't really see a big change in it for whatever reason. However, there's some demos out there that shows that there's a significant change of probably 10 to 25% in amperage usage. So but anyways, there's a, like I said, there's another one. I want to say it's called HEI maybe is the manufacturer, but no, Fanford, that's what it is. The model's an HEI. Fanford also makes one, just like the Power Boss. It's supposed to analyze your energy consumption and you know, monitor it. However, the only thing that I've been told about the Power Boss and this Fanford is, like I said, they're supposed to optimize your energy consumption. It's supposed to you know, lower your power bill. I don't know if I've seen that or not. I've seen the demos. Demos look good, but we tried one, like I said, where I work, and we didn't see a change. Actually, we saw an increase, which was really bizarre. So tried it on a few different loads, and it was kind of the same reading. It really didn't change, or I don't think it went up on the other readings, but for whatever reason, the reading that I was around on a 50 horse blower, it seemed to be that the consumption went up a little bit. That was a nice soft start feature, but anyway, so getting to the hardware. Fortunately, I got my camcorder plugged in here, so you can't really see too much, but I'll see if I can post a photo of this soft start at the end of the video. But this is a Baldor soft start. It is good for 40 amps on 240 volts. So basically, I guess it could withstand a 7.5 horse, and this motor here is only a 5 horse, and it's good for 26.5 amps with its service factor. So anyways, I just got this temporarily wired, so nobody get too excited. This obviously isn't the code, it's just basically for testing. And like I said, if I like the results that I see, I'll be purchasing another one and permanently tying it in. So basically, so the way this works is I've got the juice turned off over here as well, and at the contactor here. So basically, this is the soft start control, and what it's doing is basically you're breaking one of the two legs going to the motor. This is actually power coming in from the bottom side of the contactor, and that's the white one here. So I got the white one going into the bottom side of the contactor, and that white one is getting tied in over here, which goes in to the top side of the soft start. Okay, then the bottom side goes back up, comes back in here, which was the black wire. This one goes to the motor. So you got one line going to the motor full time, and you got one line going to the soft start, going through the soft start, coming back out and going back into the motor. So, and then this particular control needs what they call control voltage, and so that's what these two white wires are. They're also tied into the load side of the contactor. Now this one, the wiring schematic does not specify where this control voltage comes from. So when I talked to the local district office for Baldor, they said it didn't matter just as long as you had either 110 or 220 volts going to the control. So basically I had put it on the top side of the contactor, and when I flipped the switch, the motor would take off like normal. No matter how I adjusted the torque and the ramp, the motor would just take off like a horse. So after messing around with it, I just put it on the bottom side, and that's when it works. So it can only have control voltage going to the control when the control is in use. So when the contact breaks, you need to cut the power to the control voltage to the soft start as well. So like I said, this is just temporary, so nobody get too excited here. So okay, we are at a little 120 pounds. It should take off. So I'm going to set the camera up here, and we'll take a couple startup amp readings and kind of go from there. I've already kind of messed around with it a little bit, trying to optimize it the most. The one thing, because this compressor has got such a high inertial load, because you got a big flywheel, number one. Number two is there's a lot of friction inside the cylinders. I could not get it started with the soft start settings that were on the blower for the dust collector. So I had to basically mess with it. I had to adjust the torque. Had to adjust the torque setting to a higher setting and lower the ramp. So we'll see how this goes here. So okay, so you kind of got a feel as far as how it starts. Alright, here we go. 1, 2, 3. Try that again. So as you can see, you know, it still gets up to about 100 amps. I can still mess around with this a little bit. I'm not going to waste too much time more on this video, but it was just something that I kind of wanted to see if it worked or not. You know, a reciprocating compressor, you know, like I said, there's a lot of inertia there, and it might not work for the application. I've been checking the motor. You know, the motor's not really even, it's kind of warm, not really, but I've already run this compressor one cycle, and I did check the amps again, and because the crankcase oil was so cool, it was pulling about 26 amps. So about 20, almost 27, but the motor's good for 26.5 amps. So I was kind of freaking out there for a second that it was still pulling too high, but it's good. But then again, you know, a soft start is not for every application. You know, they say a soft start could be used for high inertial loads, which this is. But at the same time, this is kind of what I'd call a dead weight load, because there's momentum there, but there's so much friction in the cylinders that it's kind of hard for the motor to get the load rolling to a certain extent. So I might have to tweak the torque settings a little bit more yet. You know, there's a torque and ramp setting to adjust, but trying to keep the amps down as well. Now obviously it just peaks at 100 real briefly, So, you know, am I saving anything? It's hard to say, so I'll have to analyze this a little bit more, and I might actually do something a little bit more permanent for the time being and maybe run it for a week and just see once what happens. But I just wanted you guys to see kind of, you know, how a compressor handles, or a soft start handles a compressor. So I'll set the camera up here. You can actually see the pulleys and the flywheel move as well with this particular setting. So. I'm going to check the amps once again here. Okay, here we go. Okay, I do want to check something here. I do want to adjust this. That's what happens when you have, I increased the ramp time. I'm actually at full torque right now, so which tells me that soft start might not actually be a real good candidate for this compressor. There's two adjustable torque settings on here, and I'm using the one because the other one is inactive because it's only set for one torque setting. So I've got the torque setting maxed out. The only thing I've been kind of messing with right now is the actual ramp time. So I'm going to move the ramp time to 0, but move the torque setting way back and see if I can get it to do something a little bit different here. Okay, that last one I did there, I knocked 25 amps off startup. It peaked out at about 85 at the last. One thing I don't really like though is the instructions does say to when the soft start, when power is applied to the soft start, that you want to make sure that the minute or the second that power is applied, it actually starts rotating. As you can see here, it's kind of stalling out for like a half a second or so, which probably is not a big deal, but at the same time, it's not like a complete stall out where you've got 200 or you got full voltage going to your motor and it's stalling. That's when you're going to burn your windings out, because essentially you just turn this into a big magnetic field and it starts cooking itself, so it destroys itself. So I'm going to adjust the torque ever so slightly, keep the ramp the same. Okay, so I've just been messing around for the last 10 minutes trying to get it optimized. I got it down to about 89 amps max, and the motor sits there and stalls ever so slightly for about a quarter of a second or so. It's not like it turns instantly, but the one thing I do remember talking to the Baldor district office, they did say is that it can stall briefly on the initial voltage applied to the motor, but you want to keep it to a minimal. So just playing around with this right now. The motor's gotten significantly warm, but it's done a lot of starting and stopping, which is the hardest on the motor. So I don't know if this motor would have gotten this warm just with normal starting and stopping, just by flipping the switch on and off as much as I did with the soft start, because you're applying full voltage and you got a lot of inrush current. So obviously current equals heat. So we'll let it run all out here and see what happens. We're not quite 150, so it's not going to run very long, but here we go. So it's you know, it's debatable. I'm not sure if I want to hook this up a little bit more permanently and kind of keep an eye on it. At the same time, I think I'm going to talk to the other manufacturers on their soft starts and see what they can tell me. They might tell me the same thing, that you know, it's a hard starting load, this is what you're going to get, or that's what you can kind of expect. It's really no different than a refrigerant compressor, and I see a lot of people put a soft starting refrigerant compressor in the industrial industry just because they draw a lot of current on their startup, and they are fully loaded when they start. So I don't see why a soft start wouldn't work on this, but then again, I wanted to kind of test it out and see if it worked. I already had one for the dust collector, so I just kind of borrowed it, and just wanted to see how it reacted. And actually, the first time I had powered this up, the oil pressure had dropped. Basically, the oil pump itself had lost prime. And believe it or not, on that slow startup, it actually picked up prime right away. That was the one thing I was kind of nervous about by messing around with the starting of the compressor, was that the oil pump is going to take a lot longer to prime because the RPM is slowly building up the speed. But it didn't seem to affect it. So, like I said, I'm not sure if I want to hook this up permanently and let it run for about a week and see if I still want to do it or not, or if I just want to call it quits, or if I want to talk to another manufacturer and see what their thoughts are on their soft start. Single phase soft start's kind of rare, so there's, like I said, there's only 3 manufacturers that I know of that actually make one. So it's not like a 3-phase. You know, it's a totally different animal. So kind of surprised to see what I saw. I was actually kind of a little disappointed to see that the motor doesn't handle a soft start as well. It's a Baldor motor, it's a Baldor control, which really doesn't mean anything. But I just know that with the soft start of the dust collector, I think I saw a better improvement than I saw over here. Now, these both are fairly hard starting loads, but the one thing with the compressor is you not only have momentum, but you also have some friction going on in the pump here with the rings in the pressing against the cylinder walls. Now, being that this is a hydraulic or a pressure or oil, what am I looking for here? A oil pressurized pump, and it's got a hydraulic unload. The compressor actually doesn't start building pressure until the oil pressure gets high enough to close this little two-way valve here that actually will send air to the top of the unloader tower here to push down on the high pressure suction side cylinder or valve, so I can start building pressure. So it's not like, for example, if you have I'm going to use the Quincy QRT5 or a QT5 for example. It's a little bit cheaper pump. I think it's still a good pump, but there, to relieve off the head pressure, they rely off of a 1/8" copper line like this here that goes on top of the check valve of the tank, and it goes to a little unloader valve on the pressure switch. So once that pressure switch engages, it automatically starts building pressure. So when somebody says, well, you know, we have a unloading pressure switch in our compressor for loadless starts, not really. You're bleeding off the air out of the cylinder, but the minute that pressure switch closes and starts the motor, you're building pressure. So versus a centrifugal unloader on something like a Sailor Beal or Kellogg American or even the old pacemakers, they would start to build pressure once the centrifugal unloader would, the weights would close and start to build pressure. So kind of like this one here, you might start building pressure before the motor's full up to RPM, but it's got a better chance that the start caps are out of the loop and the running caps are taking over the load. So anyways, that's enough babbling for me today. Just thought I'd share this with you. Like I said, I'm a little disappointed. It's not exactly what I thought it would be. But then again, like I said, this is a high inertia load just like the dust collector. But the fact that there's a little bit more friction here versus just a freewheeling fan or a freewheeling blower. So I'll have to figure out, like I said, what I want to do here. If I want to try a different one from Fanford or Power Boss. I actually know a guy that is a Power Boss distributor who I worked with at my job, and we tried the Power Boss there, and he said that he'd be willing to get me one in to try it if I wanted to, if I was really serious about it. But going by what I see here, I might compare notes with him just to see what he's got to say. I know that as far as the energy savings, as far as lowering the voltage to the motor and saving energy as the the load of the motor changes, I don't know if I'll benefit from that, because from what I saw on the demo of the unit that we got at work, I didn't really see that. But at the same time, all these manufacturers have a fine print disclaimer that shows that it may work or may not work for your particular application. So if anything, it's just a glorified soft start. But he was telling me that for what I paid for my Baldor soft start, he could also sell me the Power Boss if I wanted to buy a Power Boss. So we'll see. I might not. The other one, that Fanford, like I said, I think they're in the United Kingdom. I seen them on the internet for, I think, $400. That's with an enclosure. So I don't know. I mean, it's $400. It's a lot of money, but it's not a lot of money, especially if you're going to save a few dollars in your energy bill because you're eliminating the high rush in current. So we'll see. I got a lot of thinking to do about it. So if anybody has any feedback on a single phase soft start, that'd be great. I'm kind of new to the single phase soft start, but if you just think about the single phase technology, with this motor here, there's a centrifugal switch, and there's also start and run capacitors. And the disadvantage to a soft start on a induction motor like this here, on a single phase induction motor that has a centrifugal start switch, or it has a start winding and a run winding, the one thing that I was told by Baldor was one of them. You want to minimize your startup time as possible, because you want to get your start caps auto sequence as soon as possible. So because they run at a higher voltage, I guess. I think there's like a higher current or higher voltage going through the start windings than what they're really designed for. The soft start's supposed to kind of help eliminate that, but at the same time, there's a fine line between hurry up and go versus slowly getting there. And if you get there too slow, you're putting a lot of stress on the start caps. So I've had this soft start on my dust collector for 4 years. Haven't changed a thing. I'm sure I'll have to adjust it now, but it's never given the motor any issue. Never had to put any new caps in or anything, so it's been good to me. But like I said, I just don't know if it's really the answer for the compressor. So like I said, I'll do some talking to a couple other manufacturers, see what their thoughts are, because they are made for a single phase application, induction capacitor start, capacitor run motors, so all the way up to 15 horse. And there's only one manufacturer I know that makes a 15 horse single phase motor, and that's Baldor. So, but there's a lot of current there too. So anyways, that's it for now. Hope you guys enjoyed this video, and if anyone has any interesting information on a single phase soft start that they know about or have had good luck with or whichever, it'd be great to know, because like I said, single phase soft start's a little bit different than three phase. Three phase, there's no centrifugal starting switch, no start caps or anything like that. You're just basically applying voltage to 120 degrees, or to three windings 120 degrees apart from each other, and you're getting an automatic rotation. So we'll see. So anyways, thanks for watching. Okay, so I'm back in the cabinet shop here, and I didn't actually hook up the soft start on the dust collector. I didn't put it back, I guess you could say. And I basically want to do a little bit more research on that soft start for the compressor, if it does work. Then maybe if I do buy another one, I'll actually put the new one on the dust collector here. Being it's a little bit lighter starting load. But anyways, I just hooked everything back up here. And the soft start used to be down here. And basically, it's just a direct online start now, and I was just amazed by the torque that motor has. So let me set the camera up here, see if I can shoot up there. One particular reason why I had the soft start on there, those belts are pretty tight, but okay, here we go. 1, 2, 3. As you can see, it's pretty snappy, but that's kind of basically going the difference between two loads between the dust collector and the air compressor. There's a lot of inertia and momentum here as well, because I'm running the fan probably about 2,700 RPMs, and the motor's, well, I'll figure 18, so almost not quite 1,000 RPMs faster than the motor, so there's a little bit more inertia there. So let's try that again. So anyway, so that's with without a soft start, and like I said, I'm going to hold off on putting it back on because I may put it back on the compressor and actually do some more testing, but I just wanted to kind of show you the difference. One of the reasons why I had the soft start on there was to kind of basically keep the belts from squealing, because those belts are pretty snug. I don't want to get them too snug because then you put a lot of excess wear on the bearings. So, one more time for good measure. And for anyone who is interested, that is a Leeson 5 horsepower farm duty motor, good for 23 amps with a 1.0 service factor. And when I had set it up for the pulley arrangement, it is pulling about 22.5 amps. So I'm a little under, which is good. So plus it's fan cooled, so it'll stay nice and cool. So anyways, thanks for watching.